All right, so we're going to do the final exam practice test. As you can see, the first three questions are no calculator test, and the question number 4 and 5, you need to use a calculator. So let's get started. Sketch the graph of y minus 1 equals 3 times x plus 1. So the first thing I want to do is I want to identify some key features of this linear function. So I know that the y-intercept, we find it by doing x equals 0. So I know that the y-intercept is y equals is 4. Same thing, let's find the x-intercept, which means that y is equal to 0. So my x-intercept is negative 4 over 3, comma 0. And for a linear function, that's all I need. So I'm going to just plot these 2 points. I'm going to sketch a graph, sketch a line across these 2 points. Before we do the sketching part, I think we can also find some key features of the second part before, so we know how to draw the axis. So I have the first thing I'm going to do, once again, is going to find the y-intercept. For b, it means that, well, that we don't have to think about it too much. We put x equals 0, and you get 0, 0,6 for the y-intercept. What about the x-intercept? In order to find the x-intercept, I think we can try to find the factored form of this equation. First, I don't like the fact that I have an a value of negative 1, so let's factor out negative 1. So it goes like x squared plus x minus 6, which is easier to factor, plus 3 times x minus 2. So I definitely know that the x-intercepts are going to be negative 3 comma 0 as well as 2 comma 0. Afterwards, let's find the vertex, the turning point, however you want to call it. It's called TP. Well, the first thing that I know is that the x-coordinate of the turning point is going to be the middle of negative 3 and 2. So that's negative 0.5. Now, knowing that the x-coordinate is negative 0.5, let's plug it into the equation. Negative 0.5 squared minus negative 0.5 plus 6. So that's going to be negative 0.25 plus 0.5 plus 6. So I think it's going to be 6.25. Now that I know all these points and all the key features, I think we're ready to sketch the graph of these two functions. First thing that I realize is that all my y values are non-negatives. My x-coordinates goes from negative 3 to 2. So I think I can graph my axis probably like here for my x. And then let's go like this for the y. And let's go that each uh, that. So that should be. Okay, so now let's plot the points. You don't have to use different colors, but for now I'm going to do it. My red color will represent the, the linear function. My y-intercept at 0, comma 4. My x-intercept at negative 4 over 3, so that's about here. So if I draw a straight line towards connecting these two lines, I think it goes like that. 0, comma 4, negative 4 over 3, comma 0. Yay, first one done. Now let's sketch the quadratic function using the green. 0, comma 6 is the y-intercept. And x-intercepts are negative 3, comma 0 and 2, comma 0. And also I know that the turning point is negative 0.5, 6.25. So that's about here. So smoothly connecting these points together, I think I got a graph like this. Now let's find the points of intersections using substitutions. So I can see I have the first point of intersection here graphically, but I don't know the exact coordinate of it. So I think I'll need to solve it algebraically. So I have one equation, a linear equation, stating that y minus 1 equals 3 times x plus 1, and the other equation stating that y is equal to negative x squared minus x plus 6. So I noticed that there are two equations here, and I have two variables, so I can use a simultaneous equation to solve the equation. Let's use a substitution method, which means that I'm going to replace the y in the first equation with the negative x squared minus x plus 6. So what I'm going to do with the substitution, it becomes negative x squared minus x plus 6 minus 1 equals 3 times x plus 1, using the substitution. And when I do that, I have one equation with one variable. So I know for sure that I have the ability to solve this question. Let's expand everything and simplify it. Negative x squared minus x plus 6 minus 1 equals 3x plus 3. So that's negative x squared minus 4x plus 6 minus 1 minus 3. So that's 5 minus 3 plus 2. Plus 2? Indeed. So let's rewrite this equation like that. And then right off the bat, I have a feeling that I don't have the ability to solve this using factoring method. So let's solve it using the quadratic formula. Quadratic formula goes like x equals negative b plus minus square root of b squared minus 4ac over 2a. So that's going to be x equals, b is 4 plus minus square root of 4 squared minus 4 times 1 times negative 2 divided by 2. And that's going to be x equals negative 4 plus minus 16 plus 8, so that's 24, divided by 2. That's x equals negative 4 plus minus. I can factor out 4, so it becomes 2 square root of 6. So my final answer is negative 2 plus minus square root of 6. So I have 2 points of intersections. I only found the x coordinates. So for each of them, I need to find the y coordinate of them. So when x is equal to negative 2 plus square root of 6, I think the easiest way to find it would be to use the first version of the equation. Y minus 1 equals 3 times negative 2 plus square root of 6 plus 1. So that's y equals to negative 3 plus 3 square root of 6 plus 1. So that's y equals negative 2 plus 3 square root of 6. So that's the first one. Negative 2 plus square root of 6, comma, negative 2 plus 3 square root of 6, close bracket. If x equals negative 2 minus square root of 6, similar thing. So that's going to be -2 minus square root of 6, comma, -2 minus 3 square root of 6, close brackets. That's the first question done. All right, let's move on to do question number 2. A geometric sequence has the terms u3 equals 25 and u5 is equal to 1. Well, the first thing that I would like to know is, to find the general term, is I want to know the u1 as well as the common ratio r. So I can either use the formula or you can just use, your big brain strategy. I like to use the formula, so let's use the formula. For the geometric sequence, I know that un is equal to u1 times r to the power of n minus 1. So that means that u3 is equal to u1 times r to the power of 3 minus 1, so that's 2. And u5 is equal to u1 times r to the power of 5 minus 1, which is 4. So I know that 25 is equal to u1 r squared, and 1 is equal to u1 r to the power of 4. So once again, I have two equations, two variables, so I think I can use substitution to solve this equation. So knowing that u1 is equal to 25 over r squared, I can use substitution. 1 equals 25 over r squared times r for 4. Cancel that. 25 r to the power of 2. 1 over 25 equals r squared. So I realize that r is equal to plus minus 1 over 5. Don't forget the plus minus sign. So I know the common ratio. So let's find the u1 based on that. So let's use a 25 equals u1 times plus minus 1 over 5 to the power of 2. I realize that no matter what value of positive or negative 1 over 5 I take, it's going to be 1 over 25 no matter what, which means my u1 is equal to 625. So I know the u1 and r's. So I know two expressions, un is equal to 625 times 1 over 5 to the power of n minus 1, or un is equal to 625 times negative 1 over 5 to the power of n minus 1. In each case, let's find the sum of all terms. So I know that finding the sum of all terms is possible because my common ratio in both cases are less than 1 or greater than equal to greater than negative 1. So using the formula, it's either going to be 625 divided by 1 minus 1 over 5. So what is that? 625 times 5? It's going to be 3,125 over 4. Or it could be S infinity is equal to 625 divided by 1 minus negative 1 over 5. Then I get 625 over 6 over 5. Then I get 3125 divided by 6. So I have two possible cases. Let's move on. Question number 3. A ship departs from a port P in the bearing of 200 degrees and travels 20 kilometers. Then the ship turns at A and sails in the bearing of 290 degrees and travels X kilometers. The final location B of the ship is 40 kilometers away from the port. So first thing, let's draw the situation. I travel in the bearing of 200 degrees, so I think we should put the port P on the top right side. So going from the true north, we rotate 200 degrees, which is a bit more than 180 degrees. So it's going to be about that way. And how long is that? That's called 20 kilometers. And we arrive at the point A. And sails in the bearing of 290 degrees and travels X kilometers. So apparently from here, once again, from the true north, 290 degrees, And that's a bit more than 270 degrees. So that's about this way. We travel x kilometers, and we arrive at point B. And apparently, the final location is 40 kilometers away from the point. So that's approximately 40 kilometers here. So the first thing that I notice is that because of the bearings, 200 degrees, which means that this angle here is going to be 20 degrees here, and also this angle is going to be 20 degrees here. So that means that the counterparts here is going to be 360 or 90 minus 20, so that's 70 degrees here. This and because of the two parallel lines and a line through that, this angle is also 20 degrees, which concludes that the angle BAP is equal to a 90 degree. It's a right angle triangle. Knowing that it is a right angle triangle, we can show that x is equal to 20 squared root of 3 by using the Pythagorean theorem. So we know that 40 squared equals 20 squared plus x squared. That's 1600 minus 400 is equal to x. So I've shown that x is equal to 20 square root of 3. Finally, knowing that this is a right angle triangle, I think we can assume what the angles B or PBA and also the BPA would be. So if you know about the special triangles of the right angle triangles, you know that if the one side is 1 and the other side is square root of 3 and the hypotenuse is 2, which seems to be this exact case right now, then the angles are fixed to be 60 degrees here and 30 degrees here. So I think we can assume that the inner part of this triangle BAP will also follow that same fashion. The one that is opposite of the one is 30 degrees. So I think this one is going to be 30 degrees. The one opposite of the square root of 3 is going to be 60 degrees. So that's 60 degrees here. So collecting all that information, I know that the bearing of B from P, well, the first part is a 200 degrees from from P to A, and then from A to B, that's a total bearing of 60 degrees. So altogether, we add it to be the bearing of B from P is 260 degrees, which coincides with the diagram that we have here. Let's move on to question number 4. So starting here, we're going to use our calculators. The triangle ABC has measurements b equals 0.87 radians, lowercase b is 5.2 centimeters, lowercase c is 4.5 centimeters. So the first thing that I know is that, let's use the graphic organizer. A equals, B equals, C equals, A equals, B equals, C equals. So I do know that uppercase B is 0.87, and the lowercase b is 5.2 centimeters, and lowercase c is 4.5 centimeters. So first thing that I notice is that I have a perfect pair for the letters B, which means that I'm going to use a sine law. Sine law goes like this. Doesn't matter how you use it, but I'm going to say that sine of 0.87 divided by 5.2 is equal to sine of c divided by 4.5. 4.5 sine of 0.87 divided by 5.2 equals sine of c. So my c is equal to arc sine of 4.5 sine of 0.87 divided by 5.2. So now let's put that into calculator, making sure that I'm in the right mode for the radian mode. So arc sine of 4.5 sine of 0.87, close bracket, divided by 5.2, close bracket. So I got approximately 0.723 radian. Now, I know that 0.723 radian is good, but at the same time, I'm wondering if I'm using it properly, because it's also possible that the, the complementary angle, pi minus this angle, is also a possibility. So if I compute that, pi minus answer, so I'm assuming that 2.42 radian is also a possibility. Now we kind of know that for part A says show that the angle C is 0.723 radian, so it's going to be only one of them. So how do I rule out the second 2.42 radian? Well, let's assume that 2.42 radian is true, and let's act as if we're finding the angle A. To find the angle A, we can do the pi minus V minus C. So that's going to be pi minus 0.723 minus 2.42. And hopefully you're seeing this coming in very soon. Sorry, not 0.723, my bad. The B was 0.87. So if you do pi, uh-oh, let's do pi minus 0.87 minus the answer, and I get approximately negative 1.47 radian, which is definitely not a true answer because we can't have a negative angle. So that rules out the answer for the second one. It's only possible that C is equal to 0.723 radian. So now that I've solved 0.723 radian for the C value, let's compute the other angles, A, and also the other length, lowercase a. Like we did um, just before, we can find the A by doing pi minus B minus C, which is pi minus 0.87 minus 0.723. Which is approximately pi minus 0.87 minus, that is approximately 1.55 radian. So that's easy, piece of cake. And then the final part, the lowercase a. We can use different methods to solve this question. I don't think using the cosine law is a good idea, so let's use the sine law one more time. I could use a cosine law, but not my preference here. So let's use the sine law using the 1.55 radian, the answer that we found here. You know what? It was a close game. It ended up being we lost 14-7. Both teams struggled offensively. So, quick tip here is to, instead of using 1.55 or whatever answers that we got, it's better to store this value as a letter. So here I'm going to store 1.5488575505, this value, as the alpha A. And then I'm going to use the 5.2 sine of alpha divided by the sine of 0.87 to be safer. So my A value is approximately 6.80 centimeters. So that concludes solving this triangle. All right, the final question. The table below shows the weight of 30 eggs. So first thing we need to do is we need to estimate the mean weight. Estimate the mean weight. Right now, we can only do estimate because we don't know the exact weight of individual eggs. So I think we're going to find the mean value. That's going to be 42.5, 47.5, 52.5, 57.5, 62.5, 67.5, 72.5. So I'm going to enter these values into the calculator. Stat, edit. And then the frequency, 2, 3, 8, 10, 4, 2, 1. Stat, calc, one variable stats, and in the list L1 and the frequency list, you need to put L2. And you produce the mean weight, and it's approximately 56 grams approximately. If it were more decimals, I would have put more, but it seems like it's an exact value of 56. So let's say that's good. Actually, 56.0, just to be safe. Part B, estimate the standard deviation. We don't have to do anything else. We just write down the standard deviation. Remember that we don't want to type in the SX. We want to go with the sigma x. So that's going to be approximately 6.85 grams. Now let's get to the cumulative frequency graph. So in order to graph the cumulative frequency, we need to first add an additional column here for the cumulative frequency. That's going to be 2, 5, 13, 23, 27, 29, and 30. Just reassuring that there are 30 eggs in total. And now let's plot. So first we need to make the axis. We want to go all the way to 30, so that's going to be that's 30. So let's say each of them is going to be a 5. For the x-axis, I want to go from 40 to 75 with 5 grams of increments, starting from 40, 45, 50, 55, 60, 65, 70, 75. Kind of right. That sounds good. So that's the weight and the cumulative frequency here. So let's start plotting. At 40 grams, the cumulative frequency is 0, so that's starting from 0, remember? And then at 45 mark, we have 2 in total, so that's about there. At 50, there's a total of 5. At 55, we have a total of 13. At a 60, we're at a total of 23. That's 18, 21, 23 is about there. At 65, we're at a total of 27. At 70, we're at a total of 29. At 75, we're at a total of 30. So, connecting these graphs smoothly, I get a graph like that. Now we can add one more vertical line here on the right-hand side to show the percentile. With the top being the 100%, and then the middle one being the 50th percentile. Find the percentile of an egg that weighs 62 grams. So 62 grams is approximately here. So if I go up, it's going to be around there. To the right. So for me, that looks like about 80th percentile. So my answer for part C would be the 80th percentile. All right, that finishes the video for the final exam practice test.